Good morning. If you're watching this video, it means you're having a little bit of trouble with the waves on a string remote lab. So this video is just going to kind of go through some of the parts of it, help you guys out, see if we can work through it a little bit. All right. So let me share my screen and let's get started. So main page, right? We can access it over here, or we can go to Light and Waves, subday work. There's the instructions. You should watch those already. Those are also attached in the update section right here. So everywhere. But Light and Waves, this video will probably be linked right beneath the waves on a string remote lab. But we're going to open this up, Word document, Google document, whichever you prefer. I'm going to open up a Google document. I already created my own. So that's here for me. I opened up the Google Doc and created my own copy, right? File, make a copy. So I made a copy, called it Mr. Knight's Wave on a string remote lab. And we're ready to go. So lab uses waves on a string simulation. This gives you a link to the 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 simulation. All of them links to the simulation. So I'll just open up one of them. And here's our simulation. All right. So a couple learning goals, right? Students will be able to discuss wave properties, predict wave behavior, use scientific vocabulary for wave properties and behavior, develop your understanding. We opened it up. So write a list of characteristics to describe the waves. So describe each characteristic in your own words so that a person could understand waves. Use images to help with description. So we could copy and paste some stuff here. Later during this lab, you'll rate your own descriptions to scientific ones. It is important that you have your own words to begin your learning, so don't do any research yet. Also, learning is best when you make your own drawings, but if you're working on a Google Doc, it's hard to do your own drawings. You could probably use the snipping tool and insert pictures of what you're trying to talk about. So that's good stuff there. So wave characteristics, right? If I look at this and I press oscillate here, I actually think loose and no end. Let's go no end. No end is the best for this. But what can we describe about the waves, right? What are some things that we could talk about? Now, there's things at the bottom that we could change. We could increase frequency. We could increase amplitude. So there are some things that maybe are more scientific. We could look at damping. We could look at tension, but I'm going to try and use my own words to describe some of these things. So like, excuse me, looking at this wave, right? The first thing that I see is the wave is a certain height, right? So I think one of the first descriptions I'm going to use a wave characteristic is going to be height, right? How tall the wave is. I should probably use a different color. Let's see. That can't see that at all. Let's use blue. So I've got a characteristic there, right? My characteristic is height, which tells me how tall the wave is. Easy first definition, right? B, let's talk about another thing. When I'm playing around with stuff here, it actually looks like I can change how fast the wave is going. That one looks like it's really fast. That looks really slow, so I can change speed. How fast the wave travels. Right, another good characteristic. I don't know, what else could I look at? Those are kind of the only two things that I see right off the bat to describe wave characteristics, right? How to describe the wave. I could tell you how tall it is and I could tell you how fast it's moving. Maybe I could see like how many waves are there? How quickly are the waves happening, right? We've got lots of waves. So I don't even know what we would call that. Like number or something? How quickly or how many waves there are. Right, something like that. So just a brief list. This is definitely not all inclusive, but it gives you an idea of what I'm looking for there. All right, some wave characteristics. For steps 2 through 5, investigate waves with oscillate and no end. I think I'm already on oscillate, and no end. Yes. All right. So I'm on both. There's a slow motion tool to help you slow some things down. And then we have rulers, timers, and reference lines to work with as well. Ruler, timer, reference line, all that kind of stuff that we could. Can I move the reference line? I can move the reference line. All right, cool. Use the amplitude slider. All right, answer the questions, include images. So we want to put in some screenshots here. Define amplitude in everyday language. So what does amplitude mean, right? Based on how we change, maybe I want to put slow motion. This seems really fast. Let's put this in. Maybe we put slow motion on so it's a little bit slower, but what does amplitude mean? So when I crank amplitude all the way up, this is what I'm getting. When I put amplitude in the middle, this is what I'm getting. When I put amplitude way by the bottom, that's what I'm getting. So amplitude, what is amplitude changing? We can describe that there. And then maybe we take a screenshot, right? Or use the snipping tool. We can come in here, snip this, right? Maybe draw on a little bit. Amplitude is this part, right? And I can't write with my finger. That's terrible. You guys can do way better than that. But amplitude, and then I can come back to my file and paste that in, right? That's amplitude. And maybe give a little bit of description, right? What in my words does amplitude mean? Well, it looks to me like amplitude is the height of the wave, right? Amplitude is how tall the wave is. So there's an example of what we're doing there, right? Explain how wave behaves as amplitude changes. You can describe that. And the same thing with frequency. So check out frequency, slide frequency back and forth. What does high frequency do? What does low frequency do? Answer both. Well, I can't put it on 0, low frequency. What does high frequency do? What does low frequency do? Same thing with tension, right? We've got tension over here. Right now we have high tension. What happens if we have low tension? What does that change? And the last one we can mess with is damping. What if we have lots of damping versus no damping? I'm still in slow motion. Right? What does that do to the wave? So descriptions of all of those things that we can change at the bottom. That's what I want to see. Hold the end of a real corner rope or blanket. We don't have one, so you'll probably just have to pretend and imagine, right? How can you change the amplitude? How can you change the frequency? Did you make waves that were more like manual, right? So here's manual waves or pulse waves. Oh, I still have damping way up. Right, what kind of waves did you make? Or would you make if you had a blanket or a rope? Use a simulation to show you how your real experiment would look for changing amplitude. Use the simulation to show how your real experiment would look for changing frequency. So just some descriptions there. Wave generated by oscillation paused at 2 different times. You can see here at 0 second, 0.00 and 0.2. Describe the differences and similarities, right? What does it look like? How do the waves look? You guys can do that. Make a wave with the oscillator with no damping. Measure the vertical and horizontal location of a green ball with the ruler and record the time. Use the pause button to collect the data. So we want to make a little data table here. I'll show you just a couple examples of how to get this started. We want oscillate, no damping, and I'm going to press play here. Thought I had that in slow motion for a second. Oh, I've got a really slow frequency. We might want to turn the frequency up a little bit, or maybe introduce some tension. All right, and then we want to measure a little green ball with respect to time. So I can press play and pause it, right? And we're measuring height. So here's my height ruler. We are measuring from this orange line right here. So depending on what green ball you choose, right? If I choose, I'm going to choose this green ball right here. right? This green ball is not quite, what's that? If this is 1, that's 0.2, 0.4, 0.6, 0.8, 1. So each one of these little hash marks is 0.2. So that green ball is 0.2 at 1.42 seconds. And it's actually below the line, so that's a negative 0.2. So I can come back to my thing here at what time? 1.42 seconds. The vertical distance, I just measured that. It's below the line, right? So I said it's negative, and then it's 0.2 because each one of those hashes is 0.2. So vertical, negative 0.2. And horizontal, so horizontal, maybe we start from the edge here and we're measuring this way. I'm gonna get this out of the way for a second. 1, 2, 0.2, 0.4, it looks like 2.4. Maybe right in between them, so 2.5, right? Because this would be 2.4, this would be 2.6, so 2.5. So I'm gonna go with 2.5 centimeters for that one, right? Then we pick another time. So press play, press pause again, right? I've gone to 1.98 seconds, 1.98 seconds. Measure the vertical distance again. I was using this one, so this is, it's negative still because it's below the line, and that will put me at, maybe I should be doing this in slow motion. 0.2, 0.3. Right, in between would be 0.3, negative 0.3. And if we look at the horizontal distance again, move this out of the way, 2.5 again. That didn't change at all. I'll come back here and 2.5. And we do it again, right? Until we have all our data points. Let's get one where it's above the line this time. I'm gonna get rid of this reference line here. So measuring from the orange now, right? This green ball. Now it's just about 1. So I'll put in 1. This was 2.32. Vertical is 1. Horizontal distance, if I come over here, looks like, move this out of the way, still 2.5. So that's what you're doing there. And then we're going to try and make a graph of it later on. If you want to do it on graph paper, I've got graph paper at the front of the class. If you want to do it using Excel or Google Sheets, we've kind of talked about how to do that before. So we want to make a position versus time graph for the data we just collected there. All right. Predict how the graphs would look, or how to answer a little question here. How do the graphs help you understand wave characteristics? Predict how the graphs will look if you increase the damping. Test your ideas, explain damping. You guys can do that yourselves. Investigate how waves behave with other settings, loose manual, write a little summary there. So a little brief description. And then the bottom here is just some questions that I want us to answer. We could probably use like the highlight tool to pick our answer. Maybe we use yellow highlighter there, right, to pick B, something like that. All right, so there's that. Actually, let me show you how to make the graphs before I just pretend like we should be good with that. So we want to make a graph of this. So I'm going to use Google Sheets. Open up a new sheet. We want time and vertical position and time and horizontal position. I'm actually, you'll notice as you're going through here, horizontal is always the same. So we don't really have to worry about horizontal. I might even just take that part out, but we want to worry about time and vertical position. So I'm going to copy these and insert them into my spreadsheet. There we go, right? I've got my time and I've got horizontal position. So to make a graph of this, right, I would highlight it, go to insert, chart. It picks a chart for me. We know I don't want a line chart. we've done this before. We want a scatter plot. There's my scatter plot. Dots are all over the place, right? You can see 1, 2, 3 here, but that's what we're working with. You guys will have 1, 2, 3, 4, 5, 6, 7, 8 more data points than I had here. So you should have a little bit more data than I have, but this is what we want. We just want a scatter plot, and then you can snipping tool, cut this in and paste that into the Google Doc right here. Describe the image or copy and paste it. There you go. There's my image, cut it and paste in. All right, everything else should be pretty self-explanatory. I think I hit all the big parts there as far as what to do for each section for the Waves on a String remote lab. All right, so that's what we're working on today. Hopefully that makes enough sense to you. You guys are cool with that. All right, I'm going to stop my sharing here and bid you good luck.